wanted to do a quick revision here. So yesterday, when working on this, I was thinking about what I'm calling an episode or an iteration. And basically the way it works now is each step of the agent moves the ant from one city to the next. But really what I would like is for one step to be a complete TSP traversal and give a path. And the reason why is when I look at, for example, the model data frame, if I have 100 cities and I have 100 steps right now, basically all of them have no data, and then the very last one has data. But really what I would like is for one step to mean I have a path for each ant. So now I have a bunch of paths to choose from, one for each ant, and I can have statistics around that. So really just changing this notion of what is a step, what is an episode, and so on. And I think it'll be a quick change. So I wanted to give that a quick shot. So for ant.tsp, these are my agents. I have this step function. And right now it navigates from one city to the next. I think I can just simply change this to do the full loop and then count that as one step. Let me just take a quick look at this. So so this is the model. We assign each agent to the schedule and then initialize them with the city. We'll probably have to change some of these data collection things because they won't make sense in this new paradigm. So I'll go ahead and mark this with a to-do comment. Okay, and now a step of my model. Let's see, for agent and agents, I'll be able to eliminate this because one step will do the full traversal. Okay, and then I just have this thing that checks if there's a new best path, and that should be, basically I should be able to just eliminate this and still do this check here, because I'll need to iterate through all the ants and see if one of them is best. And then I don't think I'll have a self.running equals false, because I mean, maybe I could add in a max iterations or something. Yeah, maybe I'll add in a parameter that is like the max number of things I want to run and then stop at that point, and then I can set this. So let me add in a quick. Okay. Well, let's get started then. So one thing we'll need to know is the number of cities, and I think we attach that to our model. Okay, let me minimize some of these things so that they don't distract us. Okay, let's see. All right, so we have num cities. So we should be able to do a for loop over that. And I think this will be -1 because we've already initialized new city equals self.decide next city. self.cities visited, append new city, self.model grid, move agent. Now I don't know how meaningful this moving the agent will be since I'm making multiple moves in a single step. And we're not really using this grid for much at this point. We have our own custom data structure for the graph, but it's also not going to hurt anything, so I'm going to leave it there for a moment. Okay. All right, model reporters. Num steps, where's that coming in? Okay, so this will essentially be the number of times we get solutions from the ants. I think we can keep that. Best distance, we want that. Best path, we still want that. Travel distance and cities visited. I don't think we need cities visited. Travel distance, I think we use that. I don't love the fact that we increment this here, because this function is just about deciding. I'm going to move this out. Where do we use this? Okay. Let's just... Oh, we don't have current city. Okay. That should be good. Okay, so we still want this travel distance because that represents the total distance we traversed in the thing we're trying to minimize, right? But the cities visited, I don't think we need. I mean, that is the actual set of the path. Maybe I will keep that. If I don't use it, there's no harm. Okay, so I can mark this as done. This we can eliminate. Okay, so now I'll add in my max steps. I'm going to make this a very large number. Okay. Let's go ahead and test this out. Don't have any to-dos left. We'll probably need to update this code as well. We won't even need this function. We'll just be able to call model.self, right? Or model.step, rather. Do we need? I don't know that we need to actually create a new model every time again. That might have been an artifact of this. But for now, we will keep it. Actually, that'll basically create a new data frame for my data collector every time, right? And I don't want that. I'm going to create a single model. And then this is just doing data collection that's probably not necessary, because now we will have the correct data frame. I forget what it's called. Oh, right here. All right, let's see what happens. There might be a small mistake. Okay, let's see. $26. So apparently this edge doesn't exist. So let me write out what the cities are when it fails. Oh, okay, it's the self loop. So it seems like we've reached the end. we visited all the cities. But if that's the case, why is this still going? I don't know. This is kind of weird. 97, 98. Zero. Is that some other print statement? Whoops. Key error 99. Index 0. What's happening here? Oh, I think it's because the ants already have the full list, and it's not reset at the end. I suppose that's why I was creating a new model. Maybe I will do this. First of all, I'm going to rename this. Because I don't want anyone to access this. This is like an internal attribute. And that's more a convention than enforced. But okay, so we use that here. Then once this is done, I want to set self dot So I basically want to reinitialize this after we run. But then before doing that, I want to copy it into this TSP solution. So this will basically be empty the whole time. We'll have a solution, we'll copy this over, and then we'll reset this for the next run, because this is the thing used internally. Okay. So now I need to make this the data collection thing. And then let me see if there's any other places this is used. Oh, okay. Oh, this might be a problem. I might need to change this to the TSP solution because I assume calculate pheromone delta happens later, after. Yeah, so this we should change to TSP solution. Okay. This is okay. This is okay. All right. We apparently use it here as well. Where's this at? Oh. How did I miss this? Whoops. So it has a hard time tracing these methods, the IDE, so it didn't change the symbol name of that correctly. Okay, cool. So this is working now, seemingly. We can get rid of all of this. I need to get my debugger set up so I don't have to do this through print statements. And get rid of that. Okay, I'm not sure I understand what I'm seeing here. 0, 0. Why do I have 2 zeros? I'm guessing there's an initializer that we call. Okay, not here. Data collector dot collect self. Okay. Maybe we don't need this. Okay, it seems we don't need to call that twice. And now this is probably printing the minimum overall, not the best distance just of that run. So maybe we have, this is basically the minimum of all the iterations, but maybe we should have a minimum for each iteration. something like, this is best distance globally. Let's have a best instance iter. Okay. Okay. Let's try this. It's always none. It doesn't look right. Does it need to exist at this point? Okay. So we quickly get a good solution, and then it seems to get worse. Let's see what happens if we run for, I don't know, 25 or a larger number of episodes. Still no improvement over the first. Wow, still no improvement. Okay, I'll fast forward for you guys so you don't have to wait through this. Run it for 100. Okay, I'm starting to wonder if something's wrong, because this is odd. That it seems to always choose the first solution as the best. And I also noticed if I look back at previous runs of this, we're seeing, so that's 26,000, 25,000, 26,000, 20. So it's like whatever is best in the first initial randomness, it gets locked in very quickly. So I'll troubleshoot this and probably make it a different video. I think I accomplished what I set out to here, which is to kind of change the way we were doing the steps. So there's probably an artifact of that I'm not thinking of right now, and I'll dig into that and communicate what I change. All right, I figured out the problem. It's true that if I recreate the model here over and over, it fixes it. And the reason why is related to the fact that, so this line wasn't here, sorry. Our graph, TSP graph object, we pass in to our model. And if we continue to change that graph object as we do here, that would be fine if it was that object that we kept referencing within our model, because there's only one copy of it, and they all have a reference to the same object. But what you'll see is the only thing we use the TSP graph for is to get things like the number of cities, and then the actual graph object itself we peel off here into the network grid. And I don't think the updates that we're doing to the pheromones, which is a property on the edge of this graph here, I don't think that's percolating through to this grid object. And that's why if we keep recreating this thing, we're always passing in a new TSP graph that has the updated pheromones, and that does fix our problem. So what we really need is a way to modify the graph that's attached to this thing. And there's a couple ways we could do that. One is we could add a method inside of this model, like update graph or something, which would basically replace the graph on this thing with the new graph. The other thing we could do is move. So we have a update pheromone method on our TSP graph. And right now, you pass in basically two things aside from these hyperparameters. One is this TSP graph object, and the other is the model. We could basically copy paste this method and put it under the model, and then pass in the TSP graph object. And it would update the reference to the graph that we have inside the model, instead of continually updating this TSP graph object. I don't know which solution is better. On the one hand, I had already mentioned that I didn't love having this method here because it's specific to the algorithm. Like, we could change the logic of this pheromone update, and then we would have to create like a new version of this to have two different ones. Or we could sort of dynamically inject logic as a function. But maybe it makes sense to just have this inside the model, because we will also have multiple models with different logic, I think. Like, that seems like the natural place to have colony level logic. So I think I'm going to take that route. There might be some other lurking problem that I'm not thinking of, but we'll see. So I'm just going to comment this out for now, so I can always easily reverse any damage I do. Okay, I think we're good to delete that. Now, anytime I see model, I just have to replace that with self. And anytime I see G, I need to replace that with, let's see. Wait a second. I don't even think we need this TSP graph. I think we can just keep referencing the graph we already have, right? Which was passed in originally with TSP graph. But I think we can just call self.grid.g. Okay, now instead of this, we will just simply have model.update pheromone. Okay, let's see what happens. It's looking to have the same problem. This is the graph. So wait, it looked like the pheromone was still updating on the TSP graph. Why is that? Did I not save this or something? Same problem. What am I missing? But it very quickly gets worse and worse and worse, and then just keeps getting worse. Am I doing something stupid where I'm like adding distances over and over? Like, is this a cumulative sum or something? Well, obviously not, since it's starting at infinity, but if I double this, let me see something. .6 times 2 is 5.2, times 3 is 7.8. Whoops. 10.4. Yeah, it seems to just keep adding 2.6. Oh man, I think I don't reset my agent travel distance. Oh boy. I emptied the list. Okay. So I think I had more than one problem here. So I should change this to TSP distance, and travel distance, I want to rename this to have the underscore in front of it. Okay, so for this, we want the TSP distance. That's the final thing used to calculate pheromone. This is the thing we keep track of and iterate, so we need to do that. We copy over, we reset. This we need to change, TSP distance, TSP distance. Oh, I got lucky that I noticed that it was increasing linearly. Okay, if I looked at the agent or the ant level stuff, I would have seen that. So I should probably print that as well. Okay, now we're working. All right, this is what I expected. Since we're always printing the absolute minimum from all of the runs, it never increases, but it's also not flat. We are getting progress. Cool. All right, it's fixed.